We've all been dreaming about those super capable AI agents, right? The digital assistants that can just handle complex tasks for us, no problem. But there's a huge catch. Training them is a nightmare. It's slow, it's difficult, and it is incredibly expensive. So what if we just stop training them? What if the AI could learn to teach itself?
All right, so here's our game plan for today. First, we're going to dig into the big hurdle, what's really holding these AI agents back. Then we'll introduce a totally new approach called AgentEvolver and break down the 3 core pillars that make it all work. After that, we'll look at the proof. Does it actually perform? And finally, we'll wrap up by looking at what this all means for the future of AI.
Okay, so let's start with the core problem. Why is building these smart AI assistants so ridiculously slow and expensive? Well, it all comes down to how they learn. The old way of doing things has 2 massive bottlenecks. First, you need humans, a lot of them, to sit there and painstakingly create these huge data sets of tasks for the AI to learn from. It's super manual and super slow. Second, the way the AI actually learns is often just brute force. It's this random trial and error process. Think of it like dropping someone in a maze blindfolded and just having them bump into walls until they accidentally find the exit. It's just massively inefficient.
And this really puts the difference in sharp contrast, doesn't it? The traditional way is bogged down by expensive human-made data and that clumsy brute force exploration. But this new, self-evolving approach, it completely flips the script. The AI generates its own curriculum. It uses its past successes and failures to explore smarter. It adapts on the fly. It's a fundamental shift from a passive student to an active, self-directed learner.
And this is where the solution comes in, AgentEvolver. And believe me, this isn't just a small tweak on the old methods. It's a completely new paradigm for thinking about how we train AI.
This quote from the research paper just nails the aha moment behind this whole thing. As these AI models have gotten so much better at reasoning, the researchers had this powerful thought. Wait a second, why are we still hand-holding them? Why are we still spoon-feeding them everything? Why not just let the AI take the driver's seat of its own education?
So what is AgentEvolver exactly? Well, it's not just another AI model. It's better to think of it as a complete framework, a system that lets an agent take control, actively guiding its own exploration, creating its own tasks, and figuring out how to get better, all by itself. It's an AI that's learning how to learn.
So how does this actually work? What's the secret sauce? Well, AgentEvolver isn't some single magic trick. It's actually built on 3 powerful, interconnected ideas, 3 pillars that work together to create a continuous loop of self-improvement.
And these 3 pillars are self-questioning, self-navigating, and self-attributing. So let's break down exactly what each of these does.
Okay, first up, self-questioning. This pillar is designed to tackle that huge problem of needing expensive human-made datasets from the get-go. Instead of just waiting for a human to give it a to-do list, the agent acts like a curious detective. You drop it into a new digital environment, like a new piece of software, and it immediately starts asking itself, okay, what can I do here? What's even possible? It probes the system, discovers what all the buttons and menus do, and automatically creates its own training curriculum from scratch. The second pillar is self-navigating, and this is all about fixing that wandering aimlessly in a maze problem. It's about making the exploration part of learning way, way more efficient.
So think about it like this. Rather than starting from zero, every single time it tries something, the agent builds a mental map from its past attempts. It learns from what worked, sure, but it also learned from what failed. This growing pool of experiences becomes its guide. So its exploration is no longer random, it's purposeful, it's targeted, and it cuts down on a massive amount of wasted effort. And that brings us to the final pillar, self-attributing. This is where the learning process gets really, really smart. It's all about refining how the agent learns from its specific actions.
In traditional learning, an agent might complete a 10-step task and just get a simple good job at the end. It has no idea if step 3 was a brilliant move or if step 7 was a huge mistake that it barely recovered from. Self-attributing fixes this. It lets the agent look back at the entire sequence of events and assign specific credit or blame to each individual step. That kind of precise feedback is absolutely essential for getting smarter faster.
So the theory sounds fantastic, right? A curious, map-building, self-correcting AI. But the million-dollar question is always the same. Does it actually deliver in the real world?
Let's take a look at the data. And the results are, frankly, striking. On a benchmark that tests how well an agent can use different apps, the AgentEvolver model outperformed models that were way, way bigger,
I mean, look at this. The AgentEvolver model here is running on just 14 billion parameters. The baseline models it's beating, they're using 30 billion or more. This is a huge deal. It means this method isn't just better, it's dramatically more efficient. You're getting superior performance from a smaller, cheaper, and faster model. That's the game changer. More intelligence for way less computational cost.
So, what does it mean for the future when you have an AI that's this efficient and can teach itself? Let's talk about where this is all headed.
The potential here is enormous. We're talking about the truly autonomous digital assistants we've always been promised. Imagine an AI that can teach itself how to use any new piece of software you install without waiting for a developer to train it. This makes building specialized AI agents for things like science or business or education so much more scalable and affordable. Ultimately, it paves the way for intelligent systems that can just continually adapt and improve all on their own.
This research is a major step towards truly autonomous AI, and it leaves us with one heck of a question. If AI can teach itself to master our entire complex digital world, what other worlds is it going to learn to master next?